Good morning children. In unit 1 we have learnt about various types of forces: muscular force, gravitational force, electrostatic force, magnetic force, frictional force, etc. Today we will learn about frictional force. In unit 1 you have learnt how important frictional force is in our daily life. This class we will learn about types of frictional force. Observe the activity. A book is placed on the table and it is given a push. Push is given from either side. What do you observe? Now, why does the book stop after travelling some distance? Does the book move with uniform speed? Think and discuss. Children, relative to the surface, the book is in non-uniform motion. If an object is to be in non-uniform motion, then resultant force should act on it. Let us observe the forces acting on the book placed on the table. W and N are acting in the vertical direction, capital F and small f are acting on the horizontal direction. There are two forces acting on the book in vertical direction. The gravitational force acting on the book in the downward direction, or it is the weight of the book. It is represented by capital W. Second, the normal force acting on the book due to the surface, it is represented by capital N. It is acting upwards. In the vertical direction, there is no motion. Thus, net force acting on the book is 0. W minus N is equal to 0 or W is equal to N. Hence, the weight of the book is equal to the normal force. Forces acting on the book at rest. A book is placed on the table. Let us look at the forces acting on the book at rest. The forces acting on the book at rest. The weight W acting downwards in the vertical direction, the normal reactive force acting upwards in the vertical direction, in the horizontal direction the applied force F, and in the opposite direction there is a frictional force small f acting opposite to the applied force capital F. These are the various forces acting on the book. Forces acting on the book at rest. W is equal to weight of the book acting in the downward direction, N normal reactive force acting in the upward direction. As there is no resultant force acting in the vertical direction, W minus N is equal to 0, that is W is equal to N. Hence, weight of the book is equal to the normal force, because the book is at rest and resultant force is equal to 0. The speed gradually decreases when the book is moving in the horizontal direction with respect to the surface. Now, from the activities we have observed so far, let us define the frictional force. Frictional force, the force which opposes the relative motion of two surfaces of bodies in contact is called frictional force. Now, let us know about the types of frictional force. First, let us know about static friction. Static friction is the friction that comes into play when the surfaces of the objects are at rest relative to each other. Let us once again repeat. Static friction is the friction that comes into play when the surfaces of the objects are at rest relative to each other. Static implies rest. So, static friction comes into play when the objects are at rest relative to each other. Let us see few examples of static friction. The cycle is put on the floor and there is a static friction acting between the wheels of the cycle and the surface of the floor. Let us now look into the factors affecting friction. The first one is effect of nature of surface on frictional force. Observe this activity. A ball, a bead, two cylindrical objects are moving through an inclined plane. What did you observe in this activity? Which object travelled long distance? Which object travelled small distance? Surfaces, though appear to be smooth perfect planes, consist of small irregularities. Such kind of surfaces are called irregular surfaces. Because of these irregularities between the two surfaces in contact, friction is caused. These small irregularities on the surface make the surface rough. Friction increase if the roughness of the surface increases. Thus, we conclude that friction depends on the nature of the surface. Let us look at the effect of area of contact on frictional force. Let us observe the activity. A spring balance is tightly secured to a glass slab. The surface, the horizontal surface of the glass slab is in contact with the table. Now, the spring balance is pulled. Observe the force that is applied on the glass slab. What happens if the spring balance is pulled with force? How many forces are acting on the glass slab along the straight line? When a spring balance is pulled with force, its spring is elongated. The elongation in the spring is proportional to force exerted on it. There are two forces acting on glass slab along a straight horizontal line. The force applied capital F, the frictional force small f. Now, look at the picture. The force applied by the spring balance capital F and in the opposite direction there is a frictional force acting denoted by small f. Let us look at glass slab with lesser surface of contact. The spring balance is secured with a string to the glass slab with lesser surface area of contact, and a muscular force is applied to pull the spring balance and thereby the glass slab with lesser surface of contact. Observe the force applied. What changes did you observe in static friction with change in the area of contact? We observe that in both the situations, without any relation to the area of contact, the frictional force is same. Thus, frictional force is not dependent on area of contact. Now, children, till now we have looked into two aspects. The first one, the nature of surface is dependent of the frictional force. The second one, the area of contact is independent of the frictional force. Now, let us look at the effect of normal force on friction. If a glass slab is placed over another glass slab, the force between the glass slabs increases. Therefore, frictional force is proportional to normal force. Sliding friction. Sliding friction is the friction that comes into play when the surface of one object moves relative to the surface of another object. Sliding means movement. So, sliding friction is the friction that comes into play when the surface of one object moves or slides relative to the surface of another object. Let us look into few examples of sliding friction. Observe the persons doing skating. There is a movement between the ice and the skating shoes of the person. This causes sliding friction and the person is able to slide or move. Observe the boy is sliding. So, there is a sliding friction between the boy and the surface of contact. Observe this video carefully. A person is walking on the wet land. And the person is walking carefully. He is using force to pull his legs from the wet mud. Observe the video carefully. This is our daily practice when we go through such a wet land. He is trying to balance himself when he is walking through this wet land. Did you ever happen to feel so? He is going to slip, but he is trying to balance. Observe this video carefully. The van is trying to pass through the hill. There is a smooth surface and the van is trying to pass through that. The driver is applying more speed to pass through that smooth hill, and now the horse is also trying to apply more force to pass through that smooth hill. Why this person is not able to walk in wetland? Why are we not able to walk on smooth surface properly? To walk properly without slipping in wetland or smooth surface, friction is necessary. Without friction, we cannot walk, run or do any kind of work. So, friction is necessary for doing any kind of work. Look at him. Who is he? He is a carpenter. He is trying to smoothen wooden surface. A carpenter cannot smoothen wooden surfaces if there is no friction. A girl is holding a laptop in her hands. We cannot hold objects in our hand if there is no friction. Really, does friction produce heat? Let us look through this small activity. You might have observed in a welding shop, during the sharpening of metals, sparks are produced. Sparks are produced during the sharpening of metals. Let us do a simple activity. It is a matchbox. A matchstick is taken out. and it is struck to the rough surface of the matchbox. What did you observe? Let us do the activity once again. The matchstick is struck to the rough surface of the matchbox. The fire is ignited. See, once again, when you strike your finger to the head of the matchstick, fire is produced. What did you observe when the hands are rubbed together? What did you observe when matchstick strikes the rough surface of the matchbox? Because of friction, the heat between the surfaces increases. Because of this, matchstick burns and heat is produced between the hands being rubbed. Now, children, we have observed till now by matchbox activity that friction produces heat. Now, let us learn the ways and means of reducing the friction. How to reduce friction? The material required for the activity: take a spoon, a glass of water and a coconut oil bottle. Now, place all the three on a surface: a spoon, a glass of water and coconut oil. Hold the head of the spoon with one hand and rub the other surface with bare fingers, and once again wet the hand and try to pull the surface with wet fingers. Now, the person is applying coconut oil on his fingers and he is trying to pull the surface with fingers having coconut oil. In situation 1, friction is more, and in other situations friction is less. Children, while pulling the spoon, we have used coconut oil, then the friction is reduced. So, coconut oil is used to reduce the friction between the fingers and the spoon. Coconut oil here is used as a lubricant to reduce the friction. Now, see what it is: carom board. Now, what is this person doing? He is dusting the carom board. He is applying powder all over the carom board. We all use this for making the coins move smoothly, to reduce the friction between the board and the coins. At another application, see, these are shoes and footwear. Observe the grooves in the sole of the shoes and in the footwear. These grooves reduce the friction between the surface and footwear. Now, let us look at the tires. The new tires are with proper threading and the old tires with threading worn out. When a vehicle is having old tires with threading worn out, then what will happen? We will skid. So, always we have to take care that the tires are not worn out and they have proper threading. Let us look at the effect of friction on wheels. Did you ever happen to pull a suitcase without wheels, and did you happen to pull a suitcase with wheels? In which case did you feel easy to pull and why? Let us do this activity. A book is placed on the surface and a slight push is given. A slight push is given from either side and the book moves to a certain distance. Now, let us put a series of pens in a proper order and let the book be placed on the pens. Now, with a slight push, the book is moving easily over the surface. Observe it carefully. In which case, it is easy to push the book. Why? Think about it. It is easy for a body to roll over another body than to slide over it. When one body rolls over the surface of another body, the friction offered is called rolling friction. Children, once again let us look what is rolling friction. When one body rolls over the surface of another body, the friction offered is called rolling friction. Children, in this activity we have seen that the book, when it is placed on the surface, when a push is given, it slides to a certain distance. When a series of pens are placed and a book is placed over the series of pens and a slight push is given, then it easily rolls over the surface of the pens. So, rolling is easy when compared to sliding. Let us understand the principle of ball bearing. All of you look at this spare part of a machine. The ball bearings are used in this spare part. That is one ball bearing, this is another ball bearing. So, ball bearings are used. Let us look at this activity. The top surface is to roll on the bottom surface. It is easy to roll if there are ball bearings. As you see, it is easy to roll the top surface over the bottom surface if there are balls or ball bearings. Let us do this activity with simple two lids. Take two lids and try to rotate the first lid over the second lid. Try to rotate. Are you able to rotate it properly? See the activity. Now, place a few marbles in the second lid and put the first lid over it. Now, try to rotate. See how easily the rotation is happening, and the inside marbles can be treated as ball bearings. Let us try to understand and apply the principle of ball bearings once again. Yes, what is it? What are you seeing? It is a park and the children are moving, and the children are looking very happy because they are able to rotate easily. A ball bearing is placed in the center axis and the children are able to move with a slight push. The ride is made happy because there is a smooth rotation because of ball bearings. To reduce the friction between the rotating parts of the machine tools, ball bearings are used. Now, children, let us know about fluid friction. What do you mean by fluids? Liquids and gases together are called fluids. Let us know what is fluid friction. Let us do an activity to observe fluid friction. Take a glass of water and stir it with a spoon. What is happening? The water is rotating about an axis. Observe carefully. The whirling of water stopped after a certain time. Once again stir it. The water is whirling, it is rotating about an axis, and after certain time the whirling stops. Think what happens when a spoon is placed in the whirling water. What can be the reason for the whirling water to come to rest. Children, now in this activity we have observed that the whirling of water comes to rest. Do you know why this happens? This is because there is a friction offered between the glass surface and the liquid layers that are whirling around, that are rotating around. There is a friction between the glass surface and the layers of the liquid that are whirling around. This is called fluid friction. We can see this fluid friction when a boat is moving in water. Fluid friction is exerted. By fluids, we mean that liquids as well as gases. Liquids and gases together are called fluids. Now, when we see an aeroplane going in air, there is a fluid friction that is present. When a jet plane passes through air, there is fluid friction exerted. This fluid friction exerted is called as drag. Water and other liquids exert force of friction when objects move through them. As we discussed earlier, gases and liquids together are called fluids. Fluids exert force of friction on objects in motion through them. This frictional force exerted by fluids is called drag. Now children, let us summarize what we have learnt. We have learnt about types of frictional force and the effects of area of contact, the normal force and the nature of surface in contact. Let us summarize the two types of frictional force. The first one is static friction. Static friction is the friction that comes into play when the surfaces of the objects are at rest relative to each other. Let us look into the second type of friction, sliding friction. Sliding friction is the friction that comes into play when the surface of one object moves relative to the surface of another object. We also have learnt about frictional force dependent on the nature of surface and normal force acting on it. It is not dependent on the surface area of contact. Improve your learning. Explain static and sliding friction with daily life examples. If normal force is increased twice, what happens to frictional force? Discuss. Write about factors affecting friction in your own words. Children, today in this session we have learnt about types of friction and the factors affecting friction. In the next session, we will learn more about friction. Thank you.